So we're going to look at totals in arithmetic sequences using the same symbols as before, except this time we're not finding the value of the term, we're finding the sum up to that point. It's an arithmetic sequence, so that's a constant difference, a constant addition or subtraction. But we're dealing with the matching series, so the first term in our series is 1, and their second one will be 6 because it's 1 plus the second term. Our third one will be 15 because it's 1 plus 5 plus 9, carrying on. So we're dealing with their matching totals, not the original sequence itself. And so the giveaway is the question will always ask for some word meaning total, sum, what they add up to, or some equivalent sense. Not asking for a place value along, because we would use the formula in the previous video if we were finding a particular value along the sequence. And the sum formula is this one, and it's in terms of the place along the starting value and the difference to give us our sum. So let's see how it works in practice. What do the first 20 terms of this sequence add up to? Well, we stick our values in, and this is how we know what they are. We're finding a sum because the question asks us what do they add up to. Our n is 20 because we are asked what are the first 20 terms. Our starting value a is 40, and the common difference is 5 because we're adding 5 each time. Stick it in the calculator, and there we have it, the sum 1750. Let's see how we do that in a word problem. So we want a total. What a total means we use the sum formula. That's the giveaway every time. We're told it's done 18 times from the first birthday to the 18th, so our n will be 18. The first birthday, the first amount was $100, so a is 100, and the difference is 20 more each time. Stick that into our formula. Be very careful on the calculator. Note that these square brackets are just ordinary brackets in the calculator. They're done that way to be less confusing between themselves and the formula, but we just do them as ordinary brackets on the calculator, and we're very careful because there's a lot of moving parts to this, and we get our answer 4,860. The process can also be done in reverse. So a question relating to that previous one, same situation, when we should have got at least $3,000. Well, this time we know that the sum is 3,000, and we want how many years that takes. That's our n. We stick all our values in, same as before. Our 3,000 n as our unknown, start of 100, increases of 20, and reasonable amount of algebra, and we get our answer. Note this is a quadratic at this point, so if you're solving it as a quadratic, you're going to get two answers and you have to exclude the negative one. If you're using solver on your calculator, or you're doing it by guess and check, then you just aim for the positive one, so there's no problem. So we then put that answer into words. 13.39 would mean on his 14th birthday, because you don't have a 13.39th birthday. So let's recap that. We use this formula when we have a sequence of constant differences, which we know from the D in the formula, and we want to find the total, for which S is sum, or how long it takes to get to that total.